Hey everyone, this is going to be a video about solving trigonometric equations. This is our first day on it, and we will have another day as well. Hopefully this video is quick and painless. So we're going to start off by doing problems that are actually not trig solving problems to kind of get you thinking about trigonometry really is just algebra disguised. Okay, so let's do this first problem where it says 2x squared plus x minus 1 equals 0. I'm going to factor this, and I get 2x minus 1 times x plus 1. And of course, we know that when we have something factored, we can set each of the factors equal to 0 and solve for x. So we get two answers here, x equals 1/2 and x equals -1. Now the second example has x's and y's in it, so you're going to have to solve for both x and y. And this problem is best solved by doing factoring by grouping. So hopefully that sounds familiar when you listen to that. So the first group I can factor out a 2x, and the second group I'm going to need to factor out a -1 so that I get the same thing inside my parentheses. Once I do my grouping, then I can do the next step, which is to take the factor that's the same in the parentheses, and that becomes one factor, and then I take the other pieces, and that becomes the second factor. It's really just another greatest common factor in a different form. And so for this one, I get x equals 1/2 and x equals 1. Okay, so I want you to hang on to those thoughts, because as we do the next two problems, I want you to notice the similarities, especially in the first one, and what the first one looks like in compared to the problem we just did. So we did that one on the left here, which was 2x squared plus x minus 1 equals 0. So we really have the same problem, just using cosines. So when I factor this one, it'll be 2 cosine theta minus 1 times cosine theta plus 1, all equals 0. Same thing, I'm going to set each factor equal to 0. And then I'm going to end up with an extra step. So I'm going to solve for cosine. So I get cosine here equals 1/2, and cosine here equals -1. And then I have to use my unit circle to figure out where cosine equals 1/2, and that'll be my theta answer. And notice my directions said that I wanted this between 0 and 2 pi. So these are not principal solutions. These are within the window 0 to 2 pi. So cosine is equal to 1/2 at pi over 3, and then again in the fourth quadrant at 5 pi over 3. And cosine is only equal to -1 at just pi. All right, second problem is similar to the second one we just did in the warm-up, except for I have to deal with the sine of 2 theta first. So I'm going to use one of my identities here. I'm going to use the identity that sine of 2 theta is equal to 2 sine theta cosine theta. And then I'm going to copy the rest of the problem down. And I'm going to do grouping just like I did on that first warm-up problem. So group here, group here. My first grouping, I'm going to factor out a cosine, and I am left with 2 sine theta minus 1. And in my second one, I need to factor out a -1, so I also get 2 sine theta minus 1. Okay, regroup it. I get cosine theta minus 1 times 2 sine theta minus 1. And now I set each thing equal to 0. So I get cosine of theta equals 1 and sine of theta equals 1/2. And I'm using my unit circle memory to figure out where this happens. So cosine is equal to 1, again, between 0 and 2 pi, 0 inclusive, 2 pi not. So it's only occurring at 0. Sine is equal to 1/2 at pi over 6 in the first quadrant and 5 pi over 6 in the second quadrant. All right, next ones, that last two actually. So number 5 here is asking you, where does tangent equal cotangent? Now remember, those things are reciprocals of each other. So that means that their numerators and their denominators would have to be the same in order for this to happen, which means this can only happen when the angles are your pi over 4 angles. But not just any old pi over 4 angles. They have to either both be positive or both be negative, meaning the x and the y have to both be positive or the x and the y have to both be negative in order for them to be equal to each other. So that would occur at, again, the pi over 4s, which would be first quadrant pi over 4, and then the third quadrant, which is 5 pi over 4. All right, last one is the most complicated, and it takes a few extra steps here. So notice that I have a sine and a cosine in the problem, and they're not squared, and they're not anything that I can simplify out. So what we're going to do is we're going to add that root 3 cosine theta to the other side. Or you know what? I don't want to do it that way, actually. I think I want to move the sine over, or so that I have the root by itself. So I am going to make it actually be not that. Let's say it's going to be sine of theta minus 1 equals root 3 cosine theta. That way when I go to square this, because that's what I'm going to need to do, I'm only squaring this root 3. I'm not dealing with squaring like something being added. All right, left-hand side becomes sine squared theta minus 2 sine theta plus 1, and my left side becomes 3 cosine squared theta. All right, so I still have sines and cosines, but the good news is that this is things that are squared. So notice that I have all of the sine stuff happening over here, so I'm going to leave that alone, and I'm going to change my cosine squared into its Pythagorean identity, which is 1 minus sine squared theta. If you don't remember these, you'll probably want to take out your identity sheet or someplace where you wrote identities down, so that way you have them in front of you as you're doing these problems. Okay, so now I'm going to add all of this to the left-hand side so that I can have it equal to 0. So I end up with 4 sine squared theta minus 2 sine theta minus 2 equals 0. I'm going to divide that whole thing by 2 so that I can simplify so I don't have as many large numbers. So this becomes 2 sine squared theta minus sine theta minus 1 equals 0. Like I said, this takes up quite a bit of space. And now I'm going to factor this. All right, let's see here. So I think this needs to be a negative and this has to be a positive. And then I'm going to set each one equal to 0 and solve. Okay, so let's see here. It looks like I'm going to get 3 answers. Sine is equal to negative a half at, let's see, not 5, 7 pi over 6, and 11 pi over 6. And sine is equal to 1 at pi over 2. Now, remember at the very beginning, we squared both sides of this problem, and when you square both sides, you can get extraneous solutions. So what you need to do is take all 3 of these answers, look back up at the top to the original problem here, and substitute the values in. So for instance, when I put pi over 2 in, sine of pi over 2 is 1, cosine of pi over 2 is 0, so I have 1 minus 0 is 1. That works. So this answer works. Then I have to check both of these. So when I put 7 pi over 6 in for sine of 7 pi over 6, I'll write it over here, is a negative a half. And cosine of 7 pi over 6 is negative root 3 over 2. Which should equal, let's see, positive 3 over 2 minus a half is 2 over 2. That works. But then when I put 11 pi over 6 in, this is still negative, but this part here is going to be positive, which will not equal 1. So that means I have to exclude that one. Make sure to check, because this will happen, and then there, like if there's multiple choice, that wrong answer will be there, and you might accidentally choose it. All right, hope that makes sense. Let your teacher know if you have any questions.